I'm Ryan Berry. I'm a software engineer at Canonical, and we are going to talk about multi-cloud orchestration, otherwise known as fun with Juju. And this may be an interesting definition of fun, but for a bunch of developers and DevOps people, we may have a strange idea of what is and is not fun. In particular, if it hasn't been covered, Juju is the orchestration framework for the chimes that Mike was talking about. It's Kubernetes operator day, and the chimed operator framework also runs inside Juju, but Juju is able to operate chimes as application encapsulation for previous generations of your infrastructure, whether that is VMware or bare metal or something else entirely. So we're going to go over a little bit of multi-generational model-driven operations. And I spent, like David said, about 20 years doing this, either from the DevOps or SRE side before those were actually terms. And I was just a sysadmin or as a software engineer at other open source companies. And now here, we, Canonical and others, have made Linux easy to use, where you can get to a point of solving real problems with Linux and developing your business applications instead of fighting with drivers for printers or wireless or making X work or your network cards. And one of the goals here is to do the same thing for your applications. In 2021, where so many things run as microservices, but you may still have a few legacy dependencies, we're spending an awful lot of time building the foundation for the applications, setting up Kafka and Redis and whatever your database server is, and a cluster full of Nginx proxies to go forward everything back through to your message queues. So how do we get to a point where you can worry about developing your application and not worrying about how to build everything your application stands on top of? So today we're going to go through in a little bit a demo to show how fast can we deploy and manage applications on multi-cloud clusters and substrates today. And for the purpose of the demo, I have something running in AWS and something running in microK8s, also in AWS, just for an example of a Kubernetes environment, and then something running on LXD on my local machine. And we're going to go through and show what the user experience is like, or developer experience, for deploying applications, making them talk to each other, and getting them to talk to each other across different levels of the cloud. We're going to talk about how did we do it in the past, or for some of us, how are we doing it now? A lot of those old tools are still there. Why does multi-cloud even matter? I mean, hopefully most of us know the answer to that. Like David said, only about 15% of people are all in on Kubernetes. There's a significant amount of legacy infrastructure or things which might be running inside Docker Swarm or Rancher Cattle or Mesos or Spark or something else, which is still container orchestration, but not quite Kubernetes, and those need to talk. Then once the applications are up, we'll go through and see how fast can we actually make them talk to each other. Then we'll talk a little bit about driving your applications with models and what does it actually mean. When we get our applications connected, what sort of information are they going to give each other? For some overview, infrastructure tends to have zombies or sacred cows. In this idealized world where we're whiteboarding things and started off with some bare metal or maybe a mix of bare metal and VMware or Zen or KVM or whatever your virtualization of choice may have been, to go get those legacy applications which were running in a machine that was barely utilized into something that was more maintainable and can be migrated. We hoped that eventually we'd move to bare metal, and on top of bare metal, you're running some hypervisor layer, and all your applications are running there. Maybe with pass-through for USB keys for licensing or some serial device, or you pass through NIC, but sort of all abstracted. As the rise of cloud came in, both public cloud and private cloud, you got the idea that at some point we'd run everything on top of OpenStack or OpenNebula or EC2, as it was called then, or some other kind of compute. And CERN, when they brought up the Large Hadron Collider, created a very large OpenStack cluster, and they gave a talk about how it was done. One of the analogies they came up with, which sort of stuck, was pets versus cattle. Cattle are part of a herd. They don't have names. Sure, you care about them and how many you have, but you don't care about this cow or that cow. If something goes wrong, you get rid of it and you get a new one. And this is principally what a lot of cloud native applications were built on. They're horizontally scalable. They configure themselves, or you have configuration tooling built up for them to get CI and CD. So if you're going to bring up Apache or Nginx or another Redis node or whatever it might be to scale your infrastructure, it shouldn't necessarily care. Most of the data should be on a standard volume or a volume inside EC2 or something else, or living in S3, and it can re-provision itself at runtime. This, in fact, was so pervasive that the OpenStack community for a long time fought against the idea of live migration for VMs. Not even high availability, just live migration at all, where they didn't want to add the tooling, even though libvirt already supported it, to go migrate your VMs from node to node. Because their response was essentially that if you're going to develop things on top of OpenStack, your application model should be designed in such a way they can tolerate failures. This has come up in the security vulnerabilities over the years. Various kinds of Spectre and cached look-aside errors. We can find that you see an entire Amazon AZ go down, and now you lost an entire region. The other side of CERN's analogy of pets were things that had names, things that you cared about, whether those were Active Directory servers or Microsoft SQL servers or Oracle servers. There was something that maybe scaled vertically, something that was a linchpin to your infrastructure, something where when it went down, instead of killing it and redeploying it, somebody logged into the server to go fix it. Those things didn't necessarily translate well to cloud. And moving forward in our model, where we hope that now we're running on bare metal, or we're running on public cloud or private cloud with bare metal underneath. Everything on top of that runs in Kubernetes. And on top of that, we run any application we want. You can run OpenStack, you can run VMs with Kata containers or KubeVirt, you can run something which is Kubernetes native. This is our idealized whiteboard goal. And for shops that are doing de novo development, where everything is built from scratch, the idea that it's going to be cloud native, you may be there. A lot of enterprises are not. The reality is that trying to move all these things across is really hard to do. Not every development team inside the same company, not every infrastructure team inside the same company moves at the same pace. If you are running a traditional Java or .NET monolith, which is bringing up 20 services at the same time, or it has hard-coded addresses here or there, or it doesn't have a single entry point, it may not serve itself well to being containerized. You can go fit a square peg into a round hole and you can do it, but it may not tolerate failures very gracefully. And if your Kubernetes node goes down and the pod gets rescheduled, even if it's stateful set, if there are transactions in flight for a database or something else, the recovery may cost you significant downtime. So instead of this clean whiteboard idea on top where everything is neatly separated, we have a complete mess where everything is necessarily talking to everything else. And how do we as engineers even try to manage that? Through some variety of these tools. If you're running on Kubernetes in 2021, it's probably a fair assumption that you are using Helm and Terraform and maybe a little bit of Ansible. Go build your container images. You can slap those together with Terraform or with a Docker file. You can go deploy them on top of Kubernetes, whether in Docker Hub or Quay or your own image registry, whatever it might be. Go find a Helm chart somewhere or write a Helm chart or find an operator that's a couple hundred lines of YAML, most of which is a bunch of configuration, which is really, frankly, intimidating to people who have never touched Kubernetes before, where now they have to decide about TLS termination and what they want for an ingress, and what do they want for storage, and what is a PVC, what am I looking at? There's a lot of pieces to worry about, which For the average application developer who isn't trying to be a sysadmin or a site reliability engineer, can be an overwhelming amount of boilerplate. When we moved from bare metal into the cloud, initially we started with tools like Puppet in a virtual machine, where now you can build a golden image inside VMware and go deploy it and add it to your Puppet registry. And you could say, hey, it's a web server. And Puppet would go do some of the magic of figuring out what operating system is this, what tools do I need to install, how do I bring it up, how to make sure it stays in sync. Chef did much the same thing. Chef and Knife and Chef Solo lent themselves a little bit better to bring up one-off servers, but both of these had the problem of not being agentless. So unlike Ansible as an orchestration tool, and it is an incredible orchestration tool, I don't love it as much as configuration management tool for state drift, but all of these have the problem keeping track of what is my inventory. So you made the front page of Hacker News, or you have to bring up another development environment for an internal client, and now you have more servers than you expected. How do you let Puppet or Chef know that they exist with dynamic inventory files? How do you let them know when they disappear? They have a variety of solutions that we pursued. You can have Vault, so you can try to keep more things in Git and not deal with Vault. And you might end up with some combination of infrastructure where some stuff is on Kubernetes and you're deploying that with Helm, and some stuff is still running inside OpenStack or EC2 Compute, and you are running that with CloudFormation to scale or Cloud Init for provisioning, then your Ansible point of playbook, and some stuff may still be on VMware or some other traditional virtualization solution. Now you're in a scenario where, in order to understand everything that's happening with your application and how to go deploy it and how to manage it and which pieces are which, you're talking to 4 or 5 different tools, which all have different domain-specific languages. And yes, Helm is just YAML. Very complicated YAML. And every Helm chart more or less takes different values for what you want to pass in, where even configuring a Helm chart for any given product more or less assumes that you know how to configure that product. Now, you as the developer or DevOps engineer who wants to go deploy Prometheus has to understand how to configure Prometheus. And not just how to write a config file, but that now it's an operator that's making config maps and custom CRDs and dynamically updating the Prometheus configuration. And you want to change it. So where do you even go? This is a problem that Canonical has been solving for a long time. And this is what Juju does. And this is what Juju chimes do. There's one tool that evolves with your infrastructure to go manage the software, manage everything underneath. Juju already knows how to talk to AWS and Azure and Pivotal and Oracle and Rackspace and OpenStack and LXD and Kubernetes and Mass and anything you have a kube config file for, and more than that also. The advantage of this is that you can have one tool which is able to deploy everything. Juju can set constraints like you already have inside Kubernetes, where you can set constraints in a pod, or inside AWS or OpenStack, where you can have different flavors that you want to bring up inside one templating file with one language. You can go from Metal as a service, where if your service supports IPMI, you can say, I want an Ubuntu node. And then you can say, I want that Ubuntu node I just provisioned to be an OpenStack compute node, or I want it to run kubelet. Then you can say that you want to deploy some application on top of that. You've never changed the tool that you're using. You've never changed the grammar or the verb that you're using. You've never changed the experience that you've had as a developer. Now everything is in one place. We brought a little bit of sanity back to the world. And I don't want to tell you that you won't still need Terraform if you're not deploying things that come as chimes on the Chime Hub store, where you can go search for the application that you want. And I'm not going to tell you that if you want to do very advanced configuration of some of the tools that you may not need to go touch parts of it. But for an out-of-box configuration, we can bring to the cloud, no matter what substrate you're running on, something like the same experience that you already get when you install packages from your package manager, or when you install a snap or a flatpak, where there is some default or relatively same configuration and a way for you to talk to something else instead of going to GitHub to go find it. So what we're going to do is see what a Juju controller looks like, see the status of some applications, and deploy a few. So, like I said, what I have running is Juju. And right now, the Juju controller I'm talking to knows how to talk to AWS and LexD, I'm a local host, and microK8s, which is actually right inside AWS. It also knows about OpenStack in my local lab and the LexD host locally. The controller itself is able to manage all of these. And if we look at the models, which in Kubernetes map directly namespaces, but another tool that are more of a conceptual idea, how we can manage applications, you can see that we have a model in AWS, we have a couple in Kubernetes, and we have some in LexD. So to deploy applications, there is one command. So if we want a Postgres on bare metal or inside EC2 on a regular compute, we can Juju deploy it. And if we wait a second, we will see the machine come up. So it found the charm on the charm store, and now it's deploying it. If we look at the status, it has brought up another machine inside AWS that it's pending for. And now in LexD by localhost, we can do the same thing, and we'll take a very simple charm that is hello Juju, which is really, it's a Flask application that can talk to Postgres. And we see the same thing, where it goes to go find it, and it's bringing up a LexD machine. For Kubernetes, we're in the status that we're running inside microK8s. So the microK8 charms for now use a slightly different interface, but the user experience for different interface for talking to each other, but the user experience is the same. So we can go deploy a Redis. We're deploying Discourse, so the dependencies are Redis and Postgres, and then Discourse itself. And on the Charm Hub store, most of the times you see will tell you what their dependencies are and what you need to install. So we can bring up a few, and in deploying these, I'm only using one argument, but the second name is actually the name of the application rather than the charm. So if I deploy Discourse as a second parameter, as soon as it finds this, when we look at the status, we'll see some pods coming up and the name of the applications. See, we have a Postgres and Redis, and Discourse is coming up. Some of these we're fetching an image, we're installing the agent for the controller, and we want them away in the container. The last thing we can do for the demo is, like I said, we can also manage things with YAML. And as a comparison to Helm charts, as an example, Juju is able to deploy from bundles, where we can have multiple applications deploying at once. So we can deploy Alert Manager and Prometheus and Grafana and Loki all at once. Say we want one copy of each. We're going to deploy them from Edge, which on the Charm Hub store is essentially bleeding edge. And at the bottom, as part of deployment, we can say which ones do we want to talk to each other and what relationship should they talk to each other over. So if we deploy this, the second it will go find all of these and go bring them up. While we wait for that to come up, so we can get the ones which aren't already configured to talk to each other to go do it. Spend a little time, why is any of this important at all? We covered it a little bit in the beginning, but connecting multi-tiered applications is really hard. There's a lot of moving parts. In the past, we had strategies, and now we have strategies of going through labels and tags in Google Compute or AWS, or we can use labels in OpenStack, or you can have external inventory system, which goes through VMware or Red Hat virtualization or Zen or whatever your tooling may be. There are sidecars like Linkerd and Envoy. And there's a whole world of tools. Console is a good one for connecting everything, but trying to figure out how to get your Kubernetes application, which is running inside AKS, to tell it that it needs to talk to a database server, which you're hosting yourself, because let's pretend it's not a hosted service in the public cloud. It's something you've had for a long time. You want your application to go automatically discover where it is. Maybe you have one co-located closer inside the public cloud. Maybe you're thinking about doing a migration. Maybe it's DNS server records. There's a lot of plumbing which you have to do as an administrator, which when you start moving outside of a single ecosystem, whether that is Kubernetes or OpenStack or Amazon, and start really moving into a multi-cloud or hybrid cloud environment, where the onus is now on you as the DevOps engineer or SRE to figure out how you get this application to talk to that other application. Service meshes work great for Kubernetes, and service meshes can work great for multi-cloud or hybrid cloud operations also. But for anyone who's ever done it, trying to configure a service mesh to go talk between Mesos or OpenStack running inside your development environment or your QA environment, or even your production environment running inside your own data center to talk to some application that's in a hosted Kubernetes somewhere else, so everything can go find itself out, and then doing that across multiple availability zones in the public cloud. It's a lot of work and a lot of documentation, and there isn't always an easy or quick guide, depending whether you're running Ubuntu or RHEL or Windows or SUSE, and which public cloud you're talking to, and which version of OpenStack you're running, all the different API layers, you end up handcrafting a solution every time, whether that's DNS service discovery or console, or figuring out how to plug things in, or getting Kubernetes core DNS to go talk back out to the outside world. Find yourself reinventing the wheel a lot to get these things to talk to each other. And that problem is not going to go away or resolve itself when we get through the trough of disillusionment and some of their technology picks up a little bit of the hype that Kubernetes has right now. Whether that 5 years from now, when there's something else, we can hope that Juju is going to support it, because Juju has been around for a while and supported multiple things. And when we go forward, Juju will support that too, and give you the same experience and infrastructure that you're using right now without worrying about how you have to reinvent the wheel yet again. So go back to a second to go connect all of these applications. There's status right now of the observability bundle, and this is what Michele is talking about in the session after this. I'm using this as a demonstration of how we can use a bundle, but Michele will be showing you how you can build your own charm and get it talking to this entire stack. But if you look at the status of the relations, you can see that by deploying a pretty trivial bundle YAML file, we already have Alert Manager talking to Prometheus, and Loki talking to Grafana, and Prometheus and Grafana talking to each other. They're all up. And the command for deploy that was Juju deploy, the same as it was for everything else. What's interesting is that if we switch back to AWS, you see that we have Postgres running, but how do we get it out? Well, you can go offer a Postgres, and offering, let's go pull it in from somewhere else. So if we switch to Lexi machine on my local host, we can go consume this offer by specifying the name of the model and the name of the application. And now if you look at the status of the relations, you can see that we have a software as a service. There's a Postgres, which now appears to be local, the same as anything else. So with the Juju relate command, the same as we saw earlier inside that bundle, we have a Postgres running AWS talking to hello Juju running inside my machine. And back to the Kubernetes, some of the times will tell you what they want. And so you can see that discourse, for example, wants a relation to a database. So we can go tie them together and connect Reddit to it also. Now they're all going while they figure out, they're all executing right now while they exchange information about what they need. It's one really simple set of commands to make everything work and talk to each other across multiple clouds. And the last thing is, if we look at our models, see what's up now, we can see from a single pane of glass point that there are 3 things running inside Discourse and 4 inside the observability stack, and 1 inside AWS, 1 locally. If we wanted to scale these up, since ultimately these are operators, whether inside Kubernetes or not, we can still scale the application up by itself. So let's say we want 3 copies of Postgres. Let me switch back to, like, Postgres may not actually support scaling, but on Discourse, we have some more Redis nodes. So we're scaling up to 3 units. So right now it's waiting a second. We'll see 2 more came up that are waiting for the container. 1 is waiting for the PVC. So from an operator point of view, we can scale those applications in exactly the same way as we've scaled anything else in the past. Why do we care? And Mark mentioned the idea of model-driven operations. From a development point of view, we talk a lot about domain-driven design or application-driven design. Our goal here to a point is that all of your infrastructure fits in the same headspace and the same tool. The nature of infrastructure tooling being what it is, somebody who is an SRE or DevOps will likely always have to know the nuts and bolts and nitty-gritty parts of more than one tool. But if you run a multi-cloud controller inside Juju, if you bring a new developer on or get a new laptop, if you know the credentials to the Juju controller, the authorizations to the clouds that it knows about are stored there. So if you can connect the Juju controller, you only need to know one thing to get back the same environment that you had and the same tooling. You don't need to go reconfigure everything and spend an entire day running through Ansible playbooks and configuration files to get your development environment back. Legacy and older applications don't need to get wedged in to fit your new model. When you move on to Kubernetes or whatever is past Kubernetes, wherever you're going, your legacy applications will still work as long as they're managed by Juju. And some of them, even if they're not managed by Juju, some of the Juju chimes support configuration, which you can pull out. And for some things, we have something like a proxy, like the black box exporter for Prometheus, which can go talk to things which are not managed by Juju and bring them in with some of their data. What's interesting about this is the Juju bundle that we showed earlier can also be exported from a running Juju environment. So you can dump everything out to one YAML file and lift and ship it and configure the number of units and push it from one cloud provider to another cloud provider, or one internal environment to another one, or from your laptop to production, or from production to your laptop. We take the same container model that Docker had, where you develop on your laptop and push out that you can do with Minikube. Now you can do the same thing, except with data-driven design. And this is really cool. It's really an advance in the developer experience and new developer experience. So in practice, what we need is to bring up a Juju controller, which is a Go microservice in MongoDB. On some backend, it's publicly routable. And for public cloud, this matters because if I brought up a controller on my local machine and brought something up in AWS, when the instance in AWS tried to talk back to my local machine on my home network behind a NAT, it's not going to succeed unless I punch a hole in the firewall. So for practical concerns for multi-cloud, it should be something you can route to. And inside your internal environment, if you have a VPC or you're deploying an OpenStack or some internal cloud, that may be easier. If you're trying to talk between a public cloud and your local cloud, the public cloud is probably not a bad choice. You can't have more than one Juju controller. You can have some for multiple substrates. Each one can contain multiple clouds. For this demo, we didn't do it, but you can switch between controllers just as easily as you can switch between models and get a completely different overview of a completely different environment. Then deploy your applications with one command, and that is Juju deploy. Juju deploy some app. No matter whether you're running on bare metal or AWS or Kubernetes, command is the same. Juju deploy, one application or a bundle. Everything is one command to get everything out. Status is Juju status everywhere you look. It makes it very simple. And then relates to make things speak across clouds seamlessly. And the data they're exchanging here is mostly things like database passwords. Right? If you know the IP addresses in the same Kubernetes namespace, you can always look at the service by DNS. So the information we're exchanging is not where is the service, but what do I need to talk to it, or what do I need from it? Give me a new database, give me a new Kafka queue, give me something, and here's the authentication details. Then all you need for your application is the endpoint for your app. And you can stop thinking about all the pieces to make everything else talk to everything else. Recap, managing multi-tiered clouds is easy with Juju. The goal is to make hard things easy and impossible things possible. I'd say make impossible things hard, but hopefully possible is better. And it's not actually hard, it just becomes attainable. That your data model has become service discovery. So you can still use Linkerd, or you can use Envoy, or you can use Console. But to a point, if you run Juju status and look at the status of your applications, you don't have to go plumbing through some third-party tool to find out what is advertising it and look at connections to see what is talking to what. You can export the current running state of your models and applications to lift and ship them and redeploy, or bring in your laptop with you, or as a form of disaster recovery. We won't back up your data necessarily, but as long as you have a backup, we can bring back the state of your application exactly as it was before that, which can be really nice for QA.